Today I'm going to provide a pavement management plan update. We'll talk a little bit about why pavements fail, the maintenance strategies that we have in our toolbox to address those failures, some basics on pavement management principles, and I'll go through the results of our condition assessment that was recently completed, which really sets the stage for the budget discussion moving forward. And then I will summarize some of our priority capital road projects. So what causes pavements to fail? Traffic load is an important factor. Roads that were constructed with only 3 or 4 inches of asphalt were really intended for low volume automobile traffic. They weren't designed to carry heavy commercial traffic, specifically as it relates to volume. Material quality is important and construction quality. Liquid asphalt cement or oil is really important. We need it to be flexible at low temperatures to resist cracking, and we need it to be rigid at high temperatures to avoid rutting. And the wider that temperature difference is, the more difficult it is to find a product that performs in those conditions. Utility cuts affect pavements. Trench failures, compaction of utility trenches is really the key to avoiding settlements. The pavement cuts are an opportunity for water to infiltrate into the pavement and the subgrade underneath the pavement. Soil conditions. So just like the foundation on your house, it needs to be stable and consistent. And if it's clay, for example, and swells when it gets wet, it will be reflected in the pavement above. Exposure. So exposure to the sun, just like leaving your patio furniture out all year, it gets brittle and deteriorates. The same thing happens to pavements. The freeze-thaw cycles in Colorado are severe. We have warm days and cold nights and numerous cycles throughout the year. And that constant contraction and expansion with those temperature fluctuations really accelerates deterioration. Infiltration of water. Water can get into the pavement through cracks, which then can freeze and thaw, and also affect the soil underneath the pavement. De-icing chemicals affect materials in the pavements, and drainage is really important. We need to get drainage off the street, and we need the roadside ditches to function properly to keep water from penetrating into the subgrade underneath the pavement. So we have 3 types of treatments in the toolbox. We have preservation, rehabilitation, and reconstruction. And the first we'll talk about here is preservation, which is intended to preserve. And we want to keep good roads good and extend the pavement life. We use these types of treatments on streets with minor defects and where the structure and foundation of the pavement is sound. These are the most common types here. We have the chip seal, which is inexpensive. It's a very fast process. It's waterproof and improves the skid resistance on the pavement. And in my opinion, this is really the best bang for the buck in terms of cost and benefit. Slurry seal is aggregate and emulsion, asphalt emulsion. It's very thin. It's not as flexible as a chip seal. It does crack a little bit more easily, but it's also more acceptable in a residential neighborhood setting because the surface isn't as rough. It does seal the surface, improves skid resistance as well. The cape seal is a chip seal with the slurry over the top of it. It's really the best of both worlds, but it's also more expensive. So there's no structural value to these treatments. It's strictly a surface treatment, similar to painting your house. The next step up is rehabilitation, and these are more significant treatments, and of course they're more expensive. We have hot in place recycling, where we would recycle the top inch of pavement in place, add another 1 or 2 inch overlay on top of that. The asphalt overlay, which is more common, adds 2 or 3 inches of new pavement on top of an existing surface. The mill and overlay removes 2 or 3 inches. We might do this for rutting, for example, or if there's a slope issue we need to correct, and then add a new layer of 2 to 3 inches of material again on top. Again, these treatments all need a sound foundation. These are applied on streets that are in the good to fair category, maybe right on that borderline, or maybe a higher volume road that needs more than just a preservation technique. It needs some additional structure to carry the traffic loads. These do change the structural integrity of the pavement because they are adding additional material to the structure. Then finally, we've got reconstruction, which is a last resort. There is no treatment that can save this type of condition aside from reconstruction. So structurally, the pavement's beyond repair, the foundation is damaged, and there's really no pasting it back together. These smaller pieces here shown in this photo start to pop out and a pothole forms. Obviously, there's a lot of water infiltrating the pavement and into the soil beneath the pavement, causing further deterioration. You could try to chip seal this type of pavement to hold it together on a temporary basis, but really it's throwing good money after bad, as the only answer here is to rebuild it. So that gives you a little background on the treatments we have available, and now we'll talk about the inventory and condition assessment that was recently completed on our entire network. It's collected a lot of data relative to the various distresses and the severity of those distresses. All of these data points are then consolidated into a pavement condition index, or PCI, which is what you see there in the upper right-hand corner of this slide. A number of 0 to 100 is assigned, with 100 being the best. So going down the list there, excellent is a PCI range of 91 to 100, all the way down to very poor, which has a PCI range of 0 to 45. So this information helps us plan our annual maintenance program, but more importantly, it helps us define the long-term needs on a network level. Which brings us to this concept of pavement management, which is a term we use to describe this process of looking at all the data we've collected, figuring out what is the optimal treatment and the optimal time to apply that treatment to get the best bang for the buck. We want to use the right treatment at the right time, which is not necessarily the worst first. We want to keep good roads good. That's the least expensive program we could possibly have. So to demonstrate this, we have this pavement deterioration curve over time, and on the left is the condition, excellent to very poor, and the curvy line is how a pavement deteriorates over time. So $1 spent early on in the life cycle keeps a good road good for the least amount of money. About halfway through, we see rehabilitation would cost $5 to rehabilitate a road, say in the fair category. And if we wait till the end of the pavement life, those costs are $15 to $20 to reconstruct those roads. Obviously, we want to focus our efforts on the least expensive options for as long as possible. So we can maintain more miles at a lower cost if we catch them early in the pavement life. If we wait till the end of the pavement life, fewer miles are maintained at the highest cost. So really a good program needs a mix of preservation, rehabilitation, and reconstruction to keep the overall network as a whole in good condition. So here's the actual results from our condition assessment. Our network as a whole has a PCI of 67, which is in the fair category. Now looking forward, we'll project our current condition based on a variety of different budgets. So the lines on this graph represent different budget scenarios, and based on that budget, what happens to the network condition number over time. So if we start at the bottom, the dark black line is the do nothing scenario. So if we spent no money annually on street maintenance, you can see over the next 5 years there's a pretty steep drop in condition. The next line up, the green line, is our current budget. If we spent our current budget every year for the next 5 years, it's a little bit better than doing nothing, but still on a downward trend. The blue line above that, a little bit of increase over the current budget, but again, still heading down to a lesser degree. Now when you get to the orange line, this is the budget we would need to keep the current condition at a 67 and maintains us in the fair category. The next light blue line would actually increase our overall condition to a PCI of 70. And then finally, the red line at the top is an unconstrained budget. In a perfect world with all the money we need to maintain our system, we could maintain our network in a good category. Now here's the dollars associated with those various scenarios. So if we do nothing, in 5 years our condition drops to a 47, which puts us into the poor category, and that's an annual budget of 0 if we spent no money on street maintenance. If we continued at our current budget, our PCI in 5 years is 56. Remember, we're currently at 67, and that's only an annual budget of 373. We increase a little bit of annual budget to maintain a PCI of 60 in 2025. That would be 1.1 million per year. If we want to maintain the current PCI of 67 in the fair category, the annual budget needed is 1.8 million. To improve our PCI to a 70, that annual budget is 2.1 million. And again, the unconstrained brings us up to an 81, which brings us up to the good category. That would be a 2.9 annual budget. Now let's go back to the deterioration curve, and you can see the red dot in the middle is our current PCI of 67. And it's right on the cusp there between sort of the flat part of the curve and the steep part of the curve. And off to the right, we know that those options are only reconstruction and costly reconstructions. The white dot represents where we'll be if we continue with the same budget we have now, which is that PCI of 56. And the blue dot is if we increase our budget significantly up to 2.1 million, moves us up onto the flatter part of that deterioration curve. So that wraps up our maintenance needs. I'm going to talk now a little bit about the capital needs. We'll look at each of these individually in a moment, but just a quick summary. We have in the capital project list 3rd Street from 34.5 to County Road 36, that's 1.8 million. 3rd Street and Welker Avenue intersection, 1.2 million. State Highway 66 at Weld County Road 7. Intersection and underpass improvements at 6.5 million, and a variety of trail connections to schools and parks at 5.3 million. Some of these will have additional funding sources. They have developer contributions, grants, URA funds, in addition to town contributions. 3rd Street from County Road 34.5 to 36. I do have preliminary design in hand for this right now. It includes reconstruction of 2 lanes, plus extending the regional trail from the Featheridge subdivision to the new Highlands subdivision. And there is a contribution from the Highlands for a portion of that trail construction that could be applied. This again is a design effort at this point. There are not funds identified for construction. The 3rd and Welker intersection is currently in the design phase. I have a traffic engineer who's working on this intersection design. We do have money in the budget for design this year. The Highlands development has also contributed some funds towards this project, as will other developments as they come online. And I believe we will be looking into possibly utilizing some URA funds for this intersection as well. State Highway 66 and Weld County Road 7. As you know, there's a need for intersection improvements here. CDOT is contributing to that and also spearheading the design, which includes turn lanes, a traffic signal, trail connections, extension of the box culvert, and we'd like to incorporate the underpass into this project as well. The underpass has grant funding available, and so it would make sense that we could consolidate all of these into one effort and only impact the traveling public one time. Related to the underpass, we have some trail connections that need to be made in order to utilize it here. The blue line is the existing trail that starts downtown, and the red line then would be north of 66 across a development known as Mead Place. South of 66 would be across the Liberty Ranch subdivision frontage, and then continuing south, additional trail connections to get all the way to Mead High School. On the right-hand side there we have just a conceptual drawing of perhaps what that underpass might look like. And finally, we have a number of trails in our capital improvement list that would connect the rest of our park networks. So we have a route that's shown here from downtown to Mead Ponds, and then north to Highland Lake, and loop back around to Founders Park and downtown again. So that gives you a quick summary of the transportation needs that we have in place right now.